All right. Warmly welcome to the next workshop session that we are going to hold here about safe and sustainable long-term operation of nuclear power plants and optimized lifetime management and reliably executed lifetime extensions. Starting with the presentations and then the introductions of us. So my name is Antti Ketolainen. I'm a Director of Operating Plant and Waste Services from Fortum. And I'm here with my colleague Sasu.
So hello everybody, my name is Sasu Valkamo. I am the SVP Loviisa nuclear power plant.
Let's start with the company introduction and introduction a little bit what we do in the nuclear field as a Fortum. First and foremost, we are a nuclear operator and owner. Our operation or plants are consisted of a fully owned Loviisa nuclear power plant, and then we are co-owners in another Finnish nuclear facility, nuclear power plant in Olkiluoto, and co-owners in Sweden in Oskarshamn and Forsmark. That sums up to 3.2 gigawatts in total in nuclear capacity point of view. In addition to that, in addition to our existing facilities, we are currently investigating possibilities to expand our nuclear capacity in Sweden and Finland. So we are executing a so-called nuclear feasibility study by assessing possibilities and business opportunities on nuclear. Furthermore, in addition, or actually due to the fact that we are owner and operator, we are also a waste management organization. In Finland, we have our very own low and intermediate level waste repository at Loviisa, been in operation since middle of 90s. And in addition to that, we, together with another Finnish utility, TVO, we are a co-owners of Posio Oy company, which has the responsibility of final disposal of spent nuclear fuel, and they are currently in a commissioning phase of the deep geological repository, and the operation will start within a near future as the first in the world. So we can say that our expertise covers the entire life cycle of a nuclear facility, from new builds to the operating facilities, all the way to the decommissioning and disposal of the nuclear waste. And this expertise we utilize also as a benefit of our clients. So in addition that we are owner-operator, we are also a service provider. But today we will focus now, as said, on the long-term operation, and we will very much explain about the practices and processes that we have applied in Loviisa power plant.
So speaking about Loviisa, the plant that we are operating consists of two pressurized water reactors type VVER 440, and each of the plants have a capacity of 507 megawatt net. Loviisa 1 was commissioned on 1977 and Loviisa 2 was commissioned on 1980. Today we are producing approximately 10% of the electricity need in Finland, and we have now achieved new operating licenses or received new operating licenses that are extending until the end of 2050. So the question actually is, how did we make this happen, and how was it possible? So when we constructed the Loviisa plant, first of all, we modified the original VVER 440 concept quite drastically. Even in that first days of the project, the Western safety standards and the requirements were applied to the plant, and the original lifetime or the operating license was actually 30 years. Thereafter we have extended the Loviisa lifetime 2 times, And now we have valid operating licenses, like I said, until the end of 2050. It's noteworthy that we have improved the plant safety throughout the lifetime, not only during the first phases of the construction project, where we, for example, applied many safety features that were not part of the standard design at that time. We have modernized and improved the safety in that throughout the lifetime, so that today we are actually meeting the requirements imposed by our regulatory body for the new build for the core damage frequency. So we have improved by many factors the safety of the Loviisa in practice. We have also throughout the lifespan improved the production capacity and the thermal capacity by improving making modifications to our fuel, to the core, to the secondary side, etc. Throughout the journey, we have also refurbished and maintained the plant systematically and, for example, replaced the critical safety automations, automation systems, etc. But now, the second time we extended the lifetime was not just a short decision or short contemplation, but it was a tedious project that extended over 7 years period. We actually started the contemplation on 2017, where we started to look kind of at technical features and technical capacities of certain systems, and then on 2018 we actually established a project for contemplating and designing how we will implement the LTO. It was not just a technical project. We also discussed with the society. We looked at the acceptability of the nuclear in Finland. We looked at economics naturally, and look at from very many angles, but obviously at the site we were concentrating to make it possible and to make it happen. And then throughout this project we made a periodic safety review as required by the regulation, and also we made an environmental impact assessment. And then ultimately, after the Fortum board of directors decided that we will leave a formal application of extended operating license, then Finnish government made a political decision to grant, and they granted us a new operating license that was extended till end of 2050. At the same instance, we also received a new operating license for our low and intermediate level radioactive waste final repository that is located at the site. And the system in Finland is such that we are storing the operative waste and D&D waste at the site at the end of the day when the operation is over. So how to make sure now that we can run until the end of 2050? That requires kind of a strict systematic process execution of several improvements, refurbishments and component replacements. And we have organized these activities under one program. We are calling it LTOP, and we are running several tens and tens of projects and starting to prepare for those. And at the preparatory phase, when we were contemplating the decision whether or not we will extend the lifetime, we made a business case. It was a promise to our top management how we will execute the lifetime extension, and we estimated that the additional investments that are required for this extended lifetime, our estimation that the sum of those investments was adding up to 1 billion euro. Over this extended lifetime, we have estimated that we will produce with the Loviisa facilities 177 terawatt hours more clean power in Finland. And the ELTO program actually consists of 10 portfolios. We are managing the execution of these programs, projects in these 10 portfolios, and it's first and foremost is important to define a strategy for the renewals. For example, we have decided that we are implementing all the projects under so-called normal outage scenarios. We have in Loviisa so-called 4+4 philosophy for the outages, and our intention is not to extend the outages but to make all the modifications, component replacements, safety improvements, etc. during the normal outages. Second is that we need to very carefully plan the dependencies within the projects and across the different project disciplines. And third, we must be able to prioritize the order in which the projects are then finally implemented. Obviously, our capacity with this philosophy is that we cannot implement all the projects in one outage, but we need to plan in which outages certain projects then will be implemented. Here is then an example what are we considering when we are planning the replacements or projects, what are the kind of triggering factors when we are defining whether or not certain system component or structure needs some further actions. I'm not going into the details, but safety improvements is a natural one. There can be lack of spare parts or obsolescence questions, even regulatory requirements, etc., etc.
Thank you, Sasu. As Sasu explained, there's a lot of ongoing at the moment in Loviisa under this LTOP program, which is kind of concretizing the scale and extensivity of the lifetime extension. However, in addition to that, and actually to enable this long journey, which we are now on our way up to over 70 years of lifetime, it wouldn't be possible without our holistic plant lifetime management approach that we have actually developed and optimized during the operating lifetime, and on which we have put a lot of effort, especially during the past couple of decades. There are a few key factors what we have highlighted in this slide here. One thing is that the plant lifetime management, we have integrated that organizationally. We have a specific group which comprises the aging management, equipment reliability, and outage planning, so that we are able to do all these activities in optimized manner from the safety, sustainability, and cost efficiency point of view. Then, in the core of our approach is a classification. So we classify the systems and components based not only their safety point of view, but also their purpose and meaning from the operability point of view. And based on this classification, we create the systems and components. And this classification we utilized and apply on the graded approach basis to maintenance activities, to spare part management, and obsolescence management activities. Which leads to the maintenance optimization and holistic outage planning. That is also something that we are putting a lot of effort. We are optimizing our performance, the maintenance, with an aim to shorten the outages as much as feasible. And we have managed on that quite well, as our operability factors told us. And behind of this is that we have developed a certain KPIs, how we measure our performance, how we measure what is the health status of the plant and of its individual systems and components. And for this purpose, we have also tailored certain software applications. Coming back now a little bit on the LTOP, and actually in the modernization activities that we have carried out even before the LTOP. In many cases, the large modernization project for the existing facilities and facilities are complex, especially when we are talking about such modernization projects which affect on the safety. So if there are safety factors involved, these can tend to be a rather complex cases. And maybe a most typical example of these are the INC modernizations, which is a topical thing in many existing power plants which are seeking for lifetime extension. Here is a timeline showing a little bit what is our history when it comes to the renewal of INC. So Loviisa power plants, as Sasu explained, constructed in 70s, the operation in late 70s, early 80s, are based on, the INC is based on originally in purely analog technology. In the late 90s, early 2000, we carried out an extensive feasibility study to go through how we are able to bring the INC up to this date. As a result of the feasibility study, we initiated in the middle of 2000 a full turnkey project to renewal completely the existing INC from analog to digital. We managed to carry out the first phase of the renewal quite well, but then we found out that it wasn't the feasible way to continue, and eventually we ended up the contract after 10 years. So after the first phase was completed, and we restarted. We took a new beginning after that and made a new contract where we limited the scope a little bit, took a much larger responsibility on our own shoulders. One of the key learnings that we found out is that turnkey contracts are maybe not the most favorable things when we are talking about such kind of modernization activities. When again, we are talking about safety critical equipment. So, and this new beginning, new project, we managed to complete on time and on budget with that limited scope. However, since scope was limited, these modernization activities will now continue under the LTOP program. But these key lessons, what have been listed here. So the first thing, what I mentioned already, turnkey contracts, not something that we would maybe look after in the future on these kind of large-scale complex modernization activities. The strong ownership. We learned that we as a license holder, we as an owner need to take a lot of responsibility on our own shoulders to carry out the engineering activities. That means also that we have a responsibility to clearly define the design basis, clearly design the inputs for the vendors based on a functional design, top-down approach. That enables the smooth licensing and transparency basically between all stakeholders, including the vendor, us, and regulator. And also to execute, to plan this so that these can be implemented within the frames of planned outages.
And still, as a last point, so I want to, one of the last issues is that extending lifetime is not just a technological issue, it's very much of organizational issue, and taking care of the organization has right competencies and proficiency to continue the operation throughout the operating license, and also then making sure that the D&D phase thereafter is executed professionally and the safety as a first priority. We are in Nordics, in Finland, we are operating the plant on fully merchant basis. There is no mechanisms for subsidies, etc. So we must make sure that we are also profitable in the business. And the way that we are answering and maintaining the profitability is that we are excellent in our operation. And the excellence concept includes the continuous improvement and excellent safety culture as a natural part of this our operations. And the safety, of course, is the first and foremost for all of our activities, and we must value the safety in all levels in the organization, and we must understand the meaning or the safety in depth, what all the activities and what is my role in providing safe nuclear operations. The competencies of the personnel must be maintained, and we must recruit new generations for the next decades that we are still continuing the operations, and we are doing that continuously. And also we must make sure that the motivation stays on the organization, and nuclear is in that respect is very easy branch because we are purpose-driven industry, and people get natural motivation by the purpose because we are producing clean energy. And so in that respect it's easy, but we must make sure that people can also influence of their own work, so that the working environment is deemed psychologically also safe, that the people are striving and making their best and taking their responsibility and the role that we are expecting from them.
Yes, and continuing actually on the people side, I think the backbone for us and for this our success story for long-term success is the people, and is in our own engineering capabilities. That allows us to take that technical ownership, what I mentioned in respect of the INC renewals. It allows or it means that we have a holistic level understanding of the nuclear engineering. We may utilize we utilize subcontractors in the detailed system level engineering activities, but we need to keep the certain plant architectural level engineering capabilities on ourselves. And that we have had since the beginning of the Loviisa power plant, or actually starting already from the design and construction phase. We are vendor independent. This enables so that we have the ownership. We are the ones who are responsible for the plant. And this also drives us and strives us for the more continuous operational improvement towards the safe, sustainable and cost-efficient operation of the facilities. And these very capabilities we also utilize for the benefits of our clients. And these engineerings are the same who we utilize for our own facilities, and their expertise and these lessons what we have already today went through, we also provide as a value for our clients through our nuclear services.
So to conclude, some key takeaways of this presentation, and to kind of summarize, so enable for us to continue the operation until 2050. So we have to be proactive on the investment management, on the modernizations, and we have to effectively manage the whole LTOP program. And we will reach that through systematic approach, we have to have a strategy, we have to apply continuous improvement, and operational excellence is also part of our success tools.
Yes. Yes. Yes, and yeah, as said, the owner's engineering capabilities, the strong technical ownership is a key to the successful modernization activities. And as I mentioned already, these our capabilities, these our experts, we also offer to other stakeholders of the nuclear industry through our nuclear services. That's it. We thank you, all of you, for your interest towards our presentation, and we warmly welcome you to discuss more on the topic to the QA session. And furthermore, in this afternoon, we are actually on our booth G48. We are also hosting a cocktail reception. So be warmly welcome to there and continue the discussions on the long-term operation. Thank you.
Thank you.